Welcome to section 6.5, day 2, DeMoivre's theorem. What we're going to use is DeMoivre's theorem to find powers of complex numbers. Also find the nth root of complex numbers. So a couple things we need to know before we get to DeMoivre's theorem. Given two complex numbers in polar form, so you can see z sub 1 is equal to r sub 1 cosine of theta sub 1 plus I sine theta sub 1, and then z sub 2 will have the same thing as the first one, but r sub 2 and theta sub 2. So to find the product of two complex numbers in polar form, you will multiply the two r values together, but the angles you will add together. Okay? So you'll multiply the two r values together, but you'll add the thetas. With the quotient property, you will divide the r values, but you will subtract the two angles, and make sure you subtract them in the correct order. So if you're taking z sub 1 divided by z sub 2, then it's theta sub 1 minus theta sub 2. Now, your angles must be between 0 and 2 pi, including 0, not 2 pi. So here's the interval notation. So just like we've done before, we want to make sure that angle, when we add or subtract them, are between 0 and 2 pi. And if they're not, then we'll add 2 pi or we will subtract 2 pi depending on where we land. All right? So this is not DeMoivre's theorem just yet. This is just the product and quotient of complex numbers that are in polar form. So example 1, I want you to perform the operation and leave the result in polar form. So I have two complex numbers here in polar form. I want you to multiply z sub 1 and z sub 2 together. So I will write this out so you can hopefully see where these values are coming from. So first you will multiply the r values, so the 2 and the 3, so it'll be 2 times 3, and then inside we will add the angles, so cosine of 11 pi over 6 plus 5 pi over 6 plus I sine of, same thing, 11 pi over 6 plus 5 pi over 6. And then we will simplify that. 2 times 3 is 6. Cosine of 11 pi plus 5 pi would be 16 pi over 6, but we can reduce that to 8 pi over 3 plus I sine of, same thing, 8 pi over 3. Now, is 8 pi over 3 greater than 2 pi? And the answer to that is yes. 8/3 is equivalent to 2 2/3. So it's definitely bigger than 2 pi. So we need to subtract 2 pi from 8 pi over 3, find a common denominator, and that would be 8 pi over 3 minus 6 pi over 3. So that would give us 2 pi. So we'll rewrite this as 6 times cosine of 2 pi over 3 plus I sine of 2 pi over 3. So that is the product of two complex numbers that were written in polar form. So here's our final answer to that. Let's go ahead and do the next one. Now we're doing division, so we will take, in order, 2 divided by 3, and then cosine of 11 pi over 6 minus 5 pi over 6. Same thing with sine, so plus I sine of 11 pi over 6 minus 5 pi over 6. So that'll leave us with 2/3, and then 11 pi minus 5 pi would be 6 pi over 6, or pi. So this will be cosine of pi plus I sine of pi. Now is pi between 0 and 2 pi? Yep, so we are done with that one. Let's go ahead and write that z sub 1 divided by z sub 2. And there you go. So that's how you multiply and divide complex numbers in polar form. Now, DeMoivre's theorem. This allows you to raise a complex number to a power of n. So if I had the complex number z and I wanted to and I wanted to rewrite it as z raised to the power of n, then what changes in the polar form? Well, r gets raised to the n power, And then the angle gets multiplied by n. Okay, so look at that again. The r gets raised to the n power, and then the angle gets multiplied by the n. Okay, so let's go ahead and take a look at an example. 2 times cosine of 30 degrees plus I times sine of 30 degrees raised to the 4th power. So this right here, this whole thing right here represents your complex number. And it is being raised to the 4th power. Okay? So what we're going to do is take z and raise it to the 4th power. And that would be r, which is 2, raised to the 4th, times cosine of 4 times 30 degrees plus I sine of 4 times 30 degrees. So if we simplify that, 2 to the 4th is 16. Cosine of 4 times 30 is 120. Plus I sine of, same thing, 4 times 30 is 120. This one says leave answer in standard form of a plus bi. So we're going to go ahead and multiply this out. So 16 times cosine of 120, that's a reference angle of 60 degrees with an ordered pair of 1/2 square root of 3 over 2. It is in quadrant 2, so the 1/2 is negative. So that would be negative 1/2 plus square root of 3 over 2i, and then go ahead and multiply. So 16 times 1/2 is negative 8. 16 times square root of 3 over 2. The 2 and 16 we reduced to 8, so that's plus 8 square root of 3i. And that is what z to the 4th power, z representing 2 times cosine of 30 degrees plus I times sine of 30 degrees. So here's your answer in standard form of the polar complex number form raised to the 4th power. And then the last thing we're going to look at is using DeMoivre's theorem to find the indicated power of a complex number. So this is going to take a little bit more time because it's not in polar form. So we're going to have to write it in polar form, then use DeMoivre's theorem, and then convert it back into your standard complex number form. So we've got to go back, talk about how we're going to write this in polar form. We need the r and we need the theta. So if we plot the point, square root of 3 plus I, that would be in that quadrant 1. This would represent the square root of 3. That would represent the b value of 1. So you'll find the r value, which is the absolute value of the complex number. So this would be the square root of square root of 3 squared plus 1 squared. So that would be equal to 3 plus 1. So the square root of 4 is 2. So we know the r value is 2, and then we can find theta by using tangent of theta. Would be 1 over the square root of 3, which is square root of 3 over 3. So that would represent our pi over 6 reference angle, and since it's in quadrant 1, it will be pi over 6. So we know what r and theta is. So we're going to rewrite this as r, which is 2, so we're writing it in polar form, times cosine of the angle pi over 6 plus I sine of pi over 6, and then all of that is being raised to the 5th power. So now we can use DeMoivre's theorem. The 2 gets raised to the 5th. The cosine of pi over 6 gets multiplied by 5. I'm going to switch this around, but doesn't matter really. So it'll be 5 times pi over 6 plus I times sine of 5 times pi over 6. 2 to the 5th is 32. This will turn into cosine of 5 pi over 6 plus I sine of 5 pi over 6. And then since we want to write it in a plus bi form, we need to keep going. We're going to go back to complex form. So what is cosine of 5 pi over 6? Well, that's in quadrant 2. It is a pi over 6 reference angle. So this means cosine in quadrant 2 would be negative. So it would be negative square root of 3 over 2 plus sine of 5 pi over 6 is 1/2. So that would be 1/2 I, and then we can distribute the 32. So that would cancel with the 2 and get 16. So that's negative 16 square roots of 3 plus 16 I. And so that is equivalent to what we started with in the beginning, which was the square root of 3 plus I raised to the 5th power. And just to kind of give you an idea, if we expanded this out, you would have to take this times itself 5 times, which would be a lot of work. So, writing this in polar form, even though it's a little bit of work on the front end, but then using DeMoivre's theorem to figure this out is a lot easier than trying to expand this out. Also, if you remember from Algebra 2, potentially, if you use Pascal's triangle, that was when you had something like some binomial x plus 2 or whatever raised to the 7th power. You might have used Pascal's triangle to figure this out. So DeMoivre's theorem is a way to take a complex number and raise it to a power, but you have to use it in polar form. So the DeMoivre's theorem is specific to polar form. All right, so that is it with DeMoivre's theorem. You also did the product and quotient properties for complex numbers. So take a minute to write those important things down from this section, and we can talk about the rest in class.